Hello, my name's TJ Tennant. I'm the engineering manager for Firestone Consumer Products and Bridgestone Firestone Government Products for Bridgestone Americas. We're going to cover some really cool stuff today. We're going to talk a lot about tires and how they're made, the components of a tire. You're really going to learn a lot in this presentation. It's going to be really exciting. Our agenda is going to start with why are tires important? Why do you even need tires on your vehicle? We're going to talk about tire requirements, vehicle door placards, where you can get information on your tires, tire repairs, what is deflection and how does that affect your tires, applications, and we're even going to go through a little bit of tire forensics to help you kind of determine what's going on with your out-of-service tires. Tires are important mostly because they're the only thing on your vehicle that actually touches the ground. They're the things that transfer acceleration, braking, cornering forces from the asphalt or whatever surface you're on to your vehicle. They allow you to have total control of your vehicle, and today's tires are very, very high-tech and complex applications on your vehicle. Some of the requirements of tires are going to be, wet weather traction, slip, joint slap. They're going to be steer effect, noise, a lot of things that you request and require from your tires, ride, everything that you request, we try to put in the tires for you. Let's talk a little bit about size nomenclature. Passenger and light truck tires, what makes them different? How do you read and identify one versus the other? First thing, in a passenger car tire, the nomenclature, the size of the tire will start with the letter P, and that designates that tire as a passenger car tire. Here's an example, a P225 60R16. That would be an example of a passenger car tire. From a light truck application, it would start with an LT, that means light truck application, to 35 85R16, which would tell you the size of the tire. Now let's talk a little bit about those other numbers that are identified in that nomenclature. First, on the passenger car side, the P means passenger. The 225 is the cross section, and we'll talk about that in a little more detail here in a moment. And then you've got 60, which is the aspect ratio, and an R that designates that as a radial tire. Occasionally you will see a B, which designates it as a bias ply tire, and then the 16, which is the tire size. On the light truck, which is the wheel size, I'm sorry. On the light truck side, the 235 is the cross section. The 85 is the aspect ratio, which we'll define here in a moment. The R means that that tire is designated as a radial tire, and the 16 would definitely be the wheel size. Let's talk a little bit about the components that are in a tire. You've got the treads, you've got body ply, you've got bead bundles, you've got the inner liner, you've got all these things that some of you may or may not have ever heard about. Let's talk about those for a moment. First thing, the inner liner. Several years or even decades ago, almost all tires had tubes in those tires, and that's what kind of held the air. Well, technology has advanced, and now there's an inner liner in tires made of butyl rubber, and that's what keeps the tire, the air inside of the tire. No longer or very few occasional needs for a tube in the tire nowadays. Then, the bead bundles. Those are the parts of the tire that actually adhere or lock the tire to the wheel. They allow the tire to transfer all the forces that's happening on the ground through the tire and then to the steering. So that's what that does. Now, the bead filler, which is usually a very hard rubber, is located in the sidewall of the tire. And what that bead filler does is provide stability to that tire. Without that bead filler, the components in the tire may or may not be strong enough to support that tire and keep it stable on the road. And then there's the body ply cords. What those do is basically that is the carcass of the tire, and what that carcass does is really transmit those forces. You have the forces from the ground to the tread through the body carcass of the tire, or the body cords, through the wheel, and then through your suspension and your steering mechanism. And then we have the sidewall, which basically protects all the internal components of the tire from damage when you curb the tire or you run the tire off the road. And then we have belt plies. Those are pretty cool because those keep the footprint, a certain footprint, whatever that tire is designed for, on the road. Also assist the tire in preventing punctures and damage through the tread of the tire. Then we have the cap ply, usually found on most tires, and what that does is help the tire maintain its footprint and stability at very high rates of speed. That could be made of rayon or nylon or any components such as those to help do that. And then we have the tread of the tire. Now, a lot of people like the look of a tread or something like that. I kind of look at a tire and I like the look. I buy occasionally by look, but the tread is one of the most important components because that helps keep you on the road. It can provide a quiet ride. It also is very important for wet weather traction when you're driving in inclement weather. Now, let's talk a little bit about tire dimensions. Let's talk about tread width, section height, overall diameter, and aspect ratio. We mentioned some of those things a little bit earlier. Let's talk a little bit about tread width. The tread width is the distance from the outer edge of the tread to the inner edge of the tread. That's all it is. And then let's talk a little bit about section width. Now, the numbers that we mentioned earlier, 225, 235, the first number in that tire size designation is the section width. That's why occasionally you can look at a tire in the same brand or even in different brands, and the tread may look wider or a little less wide than the other, but they have the same size rating. That's where that comes from. And then the aspect ratio, here's an example. A 225/70/16 versus a 225/60/16. That 70 is the aspect ratio, and that 60 is also the aspect ratio. And what they mean is that that sidewall is 60% as tall as that tread is wide, or it's 70% as tall as that tread is wide. That's all the aspect ratio is. And then there's the overall diameter, which is really important, very important. If you decide to upsize your tire or downsize your tire, you want that overall diameter, which is the measurement from the bottom of the tire to the top of the tire, mounted on a wheel under load. It's very important to stay within about 3% of that tire diameter so that you don't change your speedometer or alter the handling of the vehicle in a major way. That could pose a very, very catastrophic safety situation if you go too large or even too small on the overall diameter. That could seriously affect the handling of the vehicle. Also, besides the speedometer, if you go too large on the overall diameter, you could have a situation where the tire could scrape the wheel well of the vehicle when you're in a turning or high maneuvering situation. Now, how does all that work together? Well, most people think, well, the tire is what carries the load. It's the air pressure in the tire that determines the load that tire is going to be able to carry. It's very, very important to maintain the proper air pressure in the tire that's on your vehicle. You're going to hear me talk about air pressure a lot throughout this presentation because it is imperatively important that you maintain the proper air pressure. How do you know what the proper air pressure of your vehicle should be? It's pretty simple. If you still have the same size tire on that vehicle that came as original equipment tire size, it's very simple. You can open your driver's side door and look at the vehicle door placard. Typically on domestic vehicles, that door placard will have the original equipment tire size and the tire pressure recommendations. It will also have the rim size, and it'll also have the gross front and rear vehicle weights on there. So if you check that and the tire that you have mounted on your vehicle is not the same size as the original equipment size that's stated on the door placard, then you may have to call your tire manufacturer directly to find out an air pressure recommendation. Then they're going to ask you a few things. One of the things they're going to ask you is the year, make, and model of your vehicle. One of the other things they're going to ask you is what size tire you have on your vehicle. Even if the size that you have on your vehicle is not the same size as the original equipment size, they can still make a proper air pressure recommendation. And that recommendation is a cold air pressure recommendation. That means that air pressure should be checked at ambient temperature. You can check your temperature on your tire after you've taken a trip or rolled on it, but that will be the hot air pressure. Under no circumstances, if you check the air pressure that's in your tire hot, never, ever let any air out of that tire. Very, very important. Now, one thing I forgot to mention is that it's important also on European vehicles and some foreign vehicles and imports. Sometimes that placard is in the glove compartment. But if you have the owner's manual for that vehicle, that information will always be located there. Now, tire deflection. This is one of the things we talked about earlier. And the tire deflection is important because that is also determined by air pressure. It's the spring rate. And you heard me talk about air pressure a lot. We're going to continue to talk about it more. It's very important. Everything in your tire, deflection, handling, fuel economy, tire wear, starts with air pressure. Proper air pressure is the key to good tire performance. Proper air pressure is also the key to vehicle fuel economy. And there are a lot of hybrid vehicles out there now with a lot of eco-type tires. Air pressure is the key to help those vehicles do specifically what they are designed to do. Now, let's get back to tire deflection. Tires should deflect. And what I mean by deflection is that as the tire rolls around and comes under load, this is the deflection process. It rolls up, it's not under load, and then it flex again. They're supposed to do that. Tires are made of rubber so that they conform to the surface of the road that you're driving on. The deflection process helps assist the tire in not bursting under impact or anything like that. But you can defeat the purpose of deflection and what all the engineers, the tire engineers from the various tire companies have designed by either overinflating that tire, and that reduces deflection, and when you go across a hump or hit that pothole, you can cause that tire to have an instantaneous air loss, or you can, in layman's term, bust the tire. Now, if you don't have enough air pressure in there, there are a myriad of things that you can cause by doing that. One of the things is, first, you can have an issue with mileage. You're going to significantly reduce the mileage on that tire and have a very high wear situation and irregular wear on that tire by not having the proper air pressure. Secondly, you're going to burn more fuel. You're going to increase the rolling resistance of that tire, meaning it's going to take more energy to push that tire across that surface of that road, which means more fuel is going to be burned. There are just a lot of things. Also handling, wet weather traction. So it's very, very important to try to maintain the air pressure in your tire as often as possible. Typically, you should check the air pressure in your passenger or light truck tire once per month. In a motorcycle, once per month. In a commercial vehicle, a big truck, at least once per month. Because tires are porous. If you look at them under a microscope, they are similar, very similar to a sponge. And tires are going to lose some air pressure on a monthly basis. So a passenger light truck, motorcycle tire, they're going to lose approximately 1 psi per month. On a commercial truck tire, you're going to lose approximately 2 psi per month. Let's talk a little bit about maintenance on your vehicle. As we said earlier, air pressure should be checked at least once a month. Irregardless of the vehicle you have, it should be checked at ambient temperature, and before you drive your vehicle, you want to do a walk around that vehicle, sort of a pre-flight check, similar to what aircraft guy does, because that way you can usually tell, especially on a touring type vehicle, whether the tire is flat. Now, here's one thing. On a pursuit vehicle, high-performance car, Corvette, Porsche, Ferrari, any of those things, you cannot tell if that tire is flat by looking at it. I'm a tire engineer. I can't even tell if that tire is flat by looking at it. That has a very stiff sidewall, purposefully so, to maintain a certain footprint and handling characteristics on the ground. So it's important that those tires are built the way that they're built, so that they work very well with those vehicles, but you cannot tell whether they're flat or not. Another thing, you really need to, going back to air pressure, check it once a month, because you cannot visually look at a tire and determine what air pressure. Even 2 or 3 air pressure loss in a tire will severely, and I mean severely, undercut the mileage on the tire, the economy of the vehicle, the handling of the vehicle, a lot of things that could jeopardize your safety in that vehicle. Let's talk a little bit about pursuit tire repair. That is a question that comes up often. I mean a lot. hey, what kind of repair should we use? Should we do a patch? Should we do a plug? Should we do a patch-plug combination? Can we patch the sidewall? Let's discuss that a little bit. First, let's talk about pursuit tires, police tires. Why are they so special? What makes them different than the tire that you may have on your Camaro or your Corvette? Well, for one thing, they're designed for pursuit applications. They're designed specifically for use with police agencies. There's a lot of testing on those tires. They're done internally with the tire manufacturers, externally with other agencies. And then, on top of that, there's a certification process that takes place with a pursuit tire. That certification is in addition to other testing and design designations for those tires. And that certification usually will happen through a few agencies here in North America. One of those agencies is Michigan State Highway Patrol. Another agency would be LA County Sheriff's Office, and occasionally California Highway Patrol. And they certify the tires on the vehicles through a very rigorous test process. Now, let's talk about repairing pursuit tires. This is a question that also comes up, and those policies vary a little bit from manufacturer to manufacturer. So if you have a question or concern about a pursuit tire and if it can be repaired, always consult that tire manufacturer. But can you repair a pursuit tire? Yes, if the injury is less than 1/4 inch, if you use the proper materials, only one repair allowed. Also, you really need to use a patch plug combination repair on any pursuit tire. There are other more involved ways to repair that tire, but please consult your tire manufacturer. Now, air pressure effects on tires. I've had some agencies, even consumers, say, well, I don't check my air pressure that often. It's not that important. I have a TPMS on my car and that kind of thing. Nothing is a surefire way to check your air pressure other than getting an air pressure gauge and verifying that air pressure yourself. Never rely on any external mechanical or electronic devices to check, even though they're very accurate in today's vehicles. It's very important to check that air pressure. There's another example. Does overinflating the tire help me with fuel economy? Well, our tests have showed very little. It may be a 1/2 gallon per mile or something, that extra overinflating that tire. And also, if you overinflate it, don't overinflate it over the maximum pressure rating on the sidewall of the tire. And that can differ from manufacturer to manufacturer and by size of the tire. But here's the very more serious drawback on that, and that is if you don't check the air pressure. Man, say for instance you have a tire and it requires 30 PSI, and then you check it again, it's down to 23. Well, you've lost quite a bit of your fuel economy on there. If you were doing 20 miles per gallon at 30 PSI, and then at 30 PSI, and then you check it again, and it's down to 23 PSI, you could go from 20 to 18 miles per gallon quite quickly. Very important to check that air pressure. Again, on tire wear, wow, I cannot express. If you have a tire, for instance, and it's supposed to get, for example, 100,000 miles and you lose 5 PSI, you could be down to 85,000 miles. You get down to 10 PSI, you're down to 60. That's 40% loss of your tire wear. That is quite a lot. Especially if you're on a pursuit vehicle, you don't get a lot of mileage on those tires, irregardless of the vehicle. A 40% loss in wear life of your tire is quite significant. So, maintain your air pressure. You're going to lose about 1 PSI per month on a motorcycle or passenger light truck tire. You're also going to lose about 1 PSI for every 10 degrees Fahrenheit drop in air pressure. So if you don't check it for 6 months, it was at 100 degrees, and then it's down to 40 degrees. In 6 months, you've lost 6 pounds, 1 PSI for every month, and then you've lost another additional 6 pounds, 1 PSI for every 10-degree drop. So that's a total of 12 PSI. At that point, you have damaged that tire beyond repair, and you need to replace that tire. So don't undo all the work that engineers such as myself and all other tire companies have done to make sure that you're safe on your tire. Now, Let's talk a little bit about nitrogen versus compressed air. This also comes up often, and there's a lot of stuff on the internet. There's a lot of stuff by word of mouth that people are saying that may or may not be true about nitrogen versus compressed air. One thing about nitrogen, you're not going to have wheel erosion or corrosion. And that's because a lot of times you go to the gas station, you put your dollar or your 75 cents in, you got to spray out half a gallon of water before you ever get to the compressed air. Well, even once you put that air in your tire, you're still going to have some water molecules and water vapor in there. Tires have a lot of steel components. As we talked initially at the beginning of this presentation, what happens when you get water or moisture on steel components? Nothing good. So it's very important. That's where nitrogen is going to also have an advantage. Nitrogen is going to also prevent or reduce deterioration by oxidation on the inner liner of the rubber and the rubber components of the tire. And nitrogen will typically help the tires run a little cooler because there is no moisture in nitrogen. The moisture conducts heat, and that's what causes the fluctuation in that air pressure and the temperatures in your tire. Now, the cons of nitrogen. It costs money. You've got to pay for nitrogen. It is quite an extensive process of installing nitrogen into your tire. They've got to vacuum the tire, put nitrogen, vacuum, put it in, vacuum it out, and put it back in 3 consecutive times per tire. That is a very time-consuming process. And then you don't know what percentage of nitrogen you're paying for. We're breathing approximately 78% nitrogen, maybe about 16% oxygen and other inert gases. How do you know that what you're paying for is actually nitrogen? Now, on the compressed air side, compressed air is free. Now, if you maintain your air compressor, you change that air dryer on there, you drain that moisture out of the tank, there is no significant advantage to nitrogen over compressed air. Another question that we get very often is, if I have nitrogen in my tires, can I add compressed air if my tire seems to be underinflated? Yes, you can. You can add nitrogen to air or air to nitrogen. So, but be duly warned that you're going to reduce the amount of nitrogen in there. But if you have maintained your compressor correctly, then there's no real advantage. All right, mounting tires. Let's talk a little bit about rim diameters and those kind of things. Back when I was a kid in South Louisiana, I'd ride, I remember my dad had some type of Ford vehicle, had a 14-inch tire on it. When was the last time any of you have seen a 14-inch wheel on a tire? Over the years, 2004, 2007, 2010 now, through size proliferation, wow, the trend is to go to a larger tire and wheeled combination. That has been the trend, and the manufacturers, whether it be tire or vehicle manufacturers, listen very closely to you, the purchasing consumer or the fleet manager. And they want to try to accommodate you as much as possible. So if they see a trend with you going to a larger size tire or a larger size wheel, they're going to try to accommodate that at the OEM level. So a lot of the pursuit vehicles, a lot of the consumer vehicles, even the commercial vehicles today have 16, 17, 18, 20, even 22-inch wheels. That is because of what the consumer, you, have requested or have requested indirectly through aftermarket purchases. Now, how does that relate to pursuit vehicles? The same thing. Pursuit vehicles now have 16, 17, 18-inch wheels. Back in 1995, the sizes on most of those vehicles, or in fact almost all of them, was a 15-inch wheel size. That is no longer true. Now, mounting the tires, especially on a pursuit vehicle or an ultra-high performance vehicle, mounting is very, very important. There is a mounting process, but proper mounting and general mounting can cause you some problems later on. You never want to strike the wheel of a vehicle that you're trying to mount a tire on with a hammer or other hard or metal instrument. You never want to do that. If you need to replace that wheel, that is something you should do, and we'll show you an example of that when we get ready to go through the forensics portion. But also you want to use the proper tools and equipment. Good gracious alive, I cannot tell you how important the lubricant is. You don't want to over-lubricate the tire and wheel. You don't want to under-lubricate them as well. And then if you have any questions, you're not sure how to properly mount your tire or your wheel, always consult the RMA mounting guidelines. RMA is the Rubber Manufacturers Association. They set the guidelines for that. They also have safety precautions. Now, when you're ready to actually mount that tire on the wheel, you want to work on a clean surface. You want to facilitate the mounting and dismounting by lubricating the tire and the wheel with the proper lubricant. It doesn't matter what brand lubricant you prefer to use. It's best to make sure they're lubricated properly. Also, you never want to use a petroleum-based or silicone lubricant. Those can, in a long-range process, damage your tire and may even cause a tire failure. So excessive lubricant can definitely cause that wheel to slip on that tire as the tire is being operated. So you want to use the proper amount of lubricant. Also, inflation and proper bead seating. Never, ever, ever, and I can't say this enough, never inflate that tire when you're trying to seat that bead over the manufacturer's maximum tire pressure rating on that tire. If you've got to go beyond the manufacturer's maximum tire pressure, then there is something wrong. You should deflate that tire, reapply the processed lube, turn it around on the wheel, and try it again. Also, never use any gases or inert gases to explode the tire to seat the bead. That should never happen. That is a very, very serious and dangerous process. So, make sure you mount that tire properly. Also, I've seen myself, a lot of times when people are mounting tires, they go through the process. I look down at the lubrication fluid or paste that they're using, and they've left the lid off, and now, from a liquid standpoint, they've added water until there's no lubricant chemical or material in there, or during using the paste lubricants, they've left the cap off and that paste has dehydrated to the point to where it's now solidified. They're still going through the process, but there is no real lubricant being applied to those tires. Wow, that can cause a lot of damage to the tire, to the wheel, and a lot of other things, so you can waste a lot of money, especially on today's very high performance pursuit tires, and run flats or ultra high performance tires. They're very difficult to mount. You really need to follow the process accordingly. Now, let's talk about tire application guidelines. New tire applications. Occasionally I get the question, hey, I didn't rotate my tires properly, so my front tires have worn out. Where should I apply the two tires? And when you apply the two tires, they should be applied biaxial, not by left or right side. I know that sounds relatively simple, but it's very important that you apply them biaxial. So, same conditions all around, same amount of wear. Best case scenario, replace all four tires. And also, going back to proper tire maintenance, you want to follow your vehicle recommendations on tire rotations. That can also be found in your owner's manual. But here's an example. Well, I've worn the two tires out. What should I do? I would always say replace all four if possible, but that is not always real world. But in a situation where you're in the wet and you're going around a curve, especially if you realize, wow, I've gone into that curve a little bit too hot, the four tires will allow you to steer neutrally through that curve. Now, if you get into a situation where you put the two new tires on the front of the vehicle, you have the used tires on the rear of the vehicle, that can really put you into a situation where you're oversteering because you've got the new tires on the front, the older tires on the rear. The new tires have a lot better water evacuation capability, so as you're going through that curve and you realize, I've gone through a little too hot, you let off the gas, that transfers the weight of the vehicle to the front, presses down on the front, you don't have as much water evacuation capabilities on the rear, it induces an oversteer situation. That is the worst case scenario for most drivers. Most vehicles, understeer is engineered into the vehicle because that's always the safest mode of operation for the general public. With that said, That's why you put the 2 new tires on the rear, not on the front of the vehicle. You come through the curve, you realize you're coming through a little too hot, it's in the rain. You let off the gas, preferably not hit the brakes, transfers the center of gravity to the front. So now you have most of the vehicle weight pressing those front tires down, and you have the newest tires, which have the best wet weather capability, on the rear. Very, very important. And it allows you to understeer through that turn. That's the safest possible mode. Now, let's talk about four-wheel drive and all-wheel drive. Wow, a lot of four-wheel drive, a lot of all-wheel drive vehicles out there. A lot of them have different applications or recommendations on tires. Always consult that vehicle owner's manual, the tire manufacturer again, and the vehicle manufacturer again. But with four-wheel drive and all-wheel drive vehicles, you never, ever want to mix sizes on those vehicles. For example, if you have a pickup truck and it's got four-wheel differential, you don't want to put a 275/60/16 on the front and a 265/60/16 on the rear. You've actually changed the gearing of those two axles. You put that vehicle into four-wheel drive, or if it's an all-wheel drive, you're going to severely damage that transaxle. Also, you don't want to mix a radial tire versus a bias tire on the same vehicle. Wow, that should never, ever happen. Those tires handle totally different. You get into a situation where you're going to rely on that vehicle's handling. That vehicle is not going to handle the way that it's designed to. Also, you don't want to mix tread patterns because the compounds, the pattern itself, especially in a wet weather situation, are going to handle very, very differently. Now, let's talk about winter tire guidelines. It's important, very important, that snow tires be applied to all four-wheel positions. Occasionally, I get into conversations with people with pickup trucks or whatever, and they put only the snow tire on the rear and a conventional all-season tire on the front. That really shouldn't happen because that can also put you into a situation where you're going to get into a big-time understeer situation and you won't be able to control the vehicle. So you also don't want to mix non-radial tires with bias. Very similar situation to applying 2 new tires. But in the snow, you're never going to have an all-season tire that performs as well as a winter tire in snow and ice conditions. I know that you see all-season written on the sidewall, but tires also, another factor of them being made of rubber, is a compounding in those tires allow them to perform better in the conditions that they are designed to. So an ultra-high performance summer tire is going to operate, it's most efficient in very high temperature ranges. An all-season tire will operate most efficiently in moderate temperature ranges. A snow tire operates at its optimum in very cold temperatures. So if you try to apply a snow tire onto a conventional vehicle in the summertime, it will never handle as well as an all-season tire designed for the same application. Very, very important. Now, I always tell people this, there is one thing that does work in winter, all-season, and snow, but I don't know if you're going to want to apply that to your vehicle. That would be the tracks on a bulldozer, but you're going to be limited to about 9 miles per hour, so I wouldn't recommend that. Now, also, rotation. Part of the maintenance program that you should install on your vehicle, and you can follow your owner's manual, which is going to be very specific. You want to try to rotate your tires approximately, on average, about every 5,000 miles. So if you have a rear-wheel drive vehicle, you're going to rotate the rear tires to the front and then cross to the rear. If it's an all-wheel drive, from the rear to the front, and then front to the rear, a cross pattern. And then if you've got front-wheel drive, down, and then cross that way. But if you have any questions, seek your owner's manual and also consult your tire or your vehicle manufacturer. Now, that ends the basic tire information portion of this presentation, and now we're going to really get into the meat and potatoes of this presentation. What a lot of you really look for is the tire forensics section. It's going to be a lot of information. It's going to be really exciting. Let's get ready to move on to that. Hello everyone. Thanks for returning. We're going to go through some out-of-service tires here. We're going to talk about why they came out of service, what caused them to come out of service, and what you could do to prevent your tires from coming out of service. Now, there is no fail-safe 100% thing you can do to prevent every tire from coming out of service, but we're going to talk about proper maintenance and things like that to help you out with this. This is our first example. This is a light truck tire, and I'm sure some of you have seen this before, and this is not the worst case scenario. Occasionally they come in and all they've got is just a tread on the top and maybe two little bead pieces on here, and they say, hey, the tire's bad. Well, there's not a lot that I can tell from that, even being a tire engineer. But as a tire engineer, when we analyze these tires and we look at them and try to determine why they came out of service, we can tell with this one. And let's do a close-up so you can really see what I want to talk about. As we look at this tire a lot closer, we can see that there's actually a nail hole right here. That nail caused this tire to deflate because of this tire size. It was probably on a dual application. The driver kept driving. He had one tire in addition at the same wheel location, and he figured he could probably make it to a place to repair this tire. Obviously, that didn't really happen as we look at this tire right here. It's very important. You have a repair, you need a repair done to your tire. It is very important to have that done as soon as possible. Otherwise, this can cause quite a significant amount of damage to your vehicle, or if this sidewall comes off, there's steel and rubber components on it. It could even cause some issues with other drivers and even pedestrians on the side of the road. So if you have an issue, you know that you've got a problem with your tire, always try to get to a tire repair facility, or in a lot of cases, such as this one, replace your tire. Let's look at the next tire. Okay, we talked a little bit about repairs and proper repairs earlier. We talked about proper repairs with the last tire that we looked at. This tire came in, a consumer assumed that this tire was defective in some way, and as we analyze this tire relatively easily, this was actually a bulb on the side. You know, you see the bumps sometimes, and we cut this to try to look and see what was going on with it. But again, on this one, we're going to take a closer look to see what may have been the culprit with this tire. So you can see here where there was a bulge in the sidewall of this tire. The cuts on there are what our engineering group did to try to see what was causing that bulge, and we took a look at it. But as we analyze the tire as a whole, which you should always analyze all tires as a whole, interior, exterior, sidewall, and tread, we found something that was more than likely the cause of this particular anomaly. As we look at the interior of the tire, we notice here that there was a repair done. Now, if a repair is not done properly, it's imperative that it's always done properly. This one's done, appears to have been done properly, but what can happen if it's not done properly? The internal components of the tire are always experiencing some type of friction. We've got an injury here. That injury works its way up through the internal components of the tire to where you get to this bulge right here. When you get to this bulge, that's where the tire issue can happen. So, you see this, immediately, do not hesitate, take that tire to your local facility to have it analyzed and or replaced. Very important. Let's take a look at the next tire. I find this particular tire extremely interesting because it's hard to really guess what happened with this. A lot of people think it's from brake lock, but you can't really assume it's from brake lock, especially with today's model vehicles and late model vehicles, because all those vehicles have anti-lock brakes. Because they have anti-lock brakes, you wouldn't particularly experience this type of anomaly. Let's look a little closer. As we look at this anomaly, we see that the tire is scraped all the way down to the belt package. Remember, we discussed that earlier. The belt packages are made of steel. So it's 10/32 down in this one area. A brake lock would not damage a tire under normal circumstances that severely. So what this actually is, this particular vehicle was towed by a tow truck, and the tow truck did not disengage the transmission system or the locking mechanisms on the drive system. This tire locked. This vehicle was towed and did this type of damage. Typically, if there's no air loss, the consumer or the owner of that vehicle would not experience anything abnormal until he started to operate the vehicle. And if he was not cognizant enough to take a look at this tire, or the tire was in the wrong position, they probably wouldn't see this, because this is a relatively small area of this tire. This tire was brought in. The consumer assumed that this was a tire failure or a tire defect, improperly so, and we were able to figure out what happened. This is really interesting. Let's look at the next tire. I really find this tire really, really interesting as well. Of course, I find all tires interesting, but especially this one, because this is a relatively new tire as well. And it was brought in, and the consumer said, hey, there's a defect here. And we looked at it. Let's take a closer look so you can see from an engineering standpoint. As you can see, there's some granular reversion here in this area. It's a localized area of damage to this particular tire, and treads aren't made that way. So we knew that there was some external component to the damage that took place to this tire. As we analyze it, we can see that, with the reversion and the other things that we see here, that this is actually a burn mark, probably from a blowtorch or some type of hot object coming in contact with the tread area. So we know that wasn't done in the factory, because the tires are not produced that way. Tread is extruded as one solid piece, no heat reversion or anything like that on it. So we know that some type of heat or heat component was applied to this particular area of the tire, which damaged this tire. Pretty easy to figure out once you have the experience, but this, again, would not be a workmanship and materials issue. Really interesting stuff. Let's look at the next tire. Here we are now with an ultra-high performance tire. Remember, we talked earlier in the first part one of this seminar that with an ultra-high performance tire, a pursuit tire, it's very difficult to tell when that tire is flat. You cannot tell visually by analyzing that tire still mounted on the wheel of a vehicle. This is a very, very similar situation. This was on a high-performance vehicle. It's a high-performance tread pattern. It was run underinflated. And I say underinflated because no one says, low air pressure anymore, because you could have the right air pressure and have some extra loads. You could have a bunch of stuff in the trunk, tactical gear, etc. But after analyzing this tire, there's some cracking right at the flex points. Let you see it a little closer. So you see the cracking on this tire at the flex points. This is a junction between the shoulder and the tread, the highest flex area of this tire. This is what would take the brunt of the deflection of this tire, especially in an underinflation situation, and cause these cracks. They're a little bit difficult to see, but this tells us that this tire was easily run with insufficient air pressure for the load that it was designed to carry. And what that means is it was either overloaded or it ran with insufficient air pressure. And these circumferential cracks around the circumference of this tire are telltale witness marks saying, hey, I was run underinflated, I did not have enough tire, so I could not operate as designed, which gave us these cracks on this tire. Awesome information, very, very good example of today's technology in effect with insufficient air pressure for the loads that we're carrying. Let's look at the next tire. We talked quite a bit in part one of this seminar about properly mounting a tire, lubricants, those kinds of things to make sure that you don't over-lubricate the tire and cause some wheel slip. You don't under-lubricate the tire and tear the bead. Wow. Brand new tire, still got the vent moles on the tread area, and we see quite a significant amount of damage to this tire. And what happened was they mounted this tire, they didn't use the proper lube or insufficient lube to mount this tire properly, and tore the bead, and as the vehicle was in operation, very high load, a lot of inflation pressure, blew out this part of the tire. Once they tear the bead, this is going to be the weakest point in this tire and cause this type of damage. Now, again, I cannot express the importance from a safety standpoint. For the life of the tire, this won't happen in every occasion with damage to the bead. You could have a slow leak or very low air pressure loss and either rapidly wear the tire or cause an over deflection, Remember I said heat is a tire's enemy, and then over time this will happen. Very important to properly lubricate a tire during the mounting process. So if you're a fleet manager and you've got guys mounting tires within your fleet, please ensure that they're properly trained, that they're following the RMA, the Rubber Manufacturers Association procedures and standards for mounting and dismounting tire. Brand new tire, no, everyone doesn't have a lot of money to replace 1 or 2 tires on their personal vehicle. From a fleet standpoint, many tires like this in your scrap bin. So let's make sure that we follow the right procedures, mounting, balancing, lubricating the tires so that you get the life out of the tire that you've paid for. Let's look at the next tire. Getting back to mounting tires, you know, we talked about proper lube and that kind of thing, but we didn't talk a whole lot about hitting wheels, or you've got a bent wheel, and what happens, or even the after effects of mounting a tire and not replacing that wheel. Really, really good example here of what happens when you have a bent wheel. I want to get in a little closer so you guys can see this a little better. What we've got here is wear occasionally around the wheel, but here is where the wheel was bent and it caused this really, really high level of damage to the tire. We know that the wheel was bent because this is the area of impact. So if the consumer or the fleet that used this tire in operation continued operation of this tire, there is no doubt ultimately you could have had a catastrophic tire failure associated with this. This was pretty easy to tell because they brought the tire and the rim assembly in together as a whole. We saw where the wheel was bent, obviously bent, caused this wear here. Again, not necessarily a defective tire. This is an issue of not properly mounting or balancing, or in the process of mounting and balancing your tire, not noticing any defects in the wheel. When you mount that tire on that wheel, you want to look for any rust or contamination or anything on that wheel that could seriously affect the operation of a tire. Let's look at the next tire. Okay, we've got our next tire. This tire is pretty exciting because a lot of you have probably seen this type of wear. This is center wear. This is a light truck tire. It's pretty easy to tell what happened with center wear is that you didn't have enough load on that truck and the contact patch was in this area instead of spread across the tire as it should be as the tire was designed, and this took the brunt of the wear, and of course the shoulder edge and the shoulder area didn't get that much wear. And this is a telltale sign of overinflation, which is just as bad as underinflation, because in a wet weather situation, this tire in its wheel position would have a very limited capacity for traction, especially if it was still in that overinflation situation where only the center is contacted. You've got less than 230 seconds, which is beyond the legal limit of 230 seconds at the wear bar. So this tire would cause some very serious problems for this particular user in a wet weather situation. Let's look at the next tire. You know, we talked a little bit about overinflation, but that is not the only category that's air pressure related. A lot of different wear can be on a tire, and there are many, many categories of wear, but I really wanted to focus on most of the categories that you, as a consumer or fleet manager, would probably see. This particular instance is not tire related. This is mechanical, and let's look at this a little closer. I really want you to get the meat and potatoes of this one. As you can see, there's a lot more wear on this side of the tire than there is on this side. All this is the same compound or similar compound across this tread area, and tread would not normally wear that way. So when I look at this tire, I know that this tire was turned in this direction, rolling that way, and it caused this side of the tire to take the brunt of the leading edge as the tire rolled down the road and basically scrub this off. Very similar to what would happen if you took the eraser on a pencil and scrubbed it on some dirt or sandpaper. It just wore this side of the tire off. Now this isn't as severe as others I've seen, but this is easily not a defect in the tire. This is easily mechanical wear instigated by an improper alignment on this particular vehicle. Really, really good stuff. Let's take a look at the next tire. This tire I really love. This is a great tire, great example of a road hazard. This particular customer is driving down the road, hears a thumping on the tire, pulls into the tire dealer as he or she should have, and this was actually stuck in the tire. I think this is a carpentry nail. But the thing that's important, this is a brand new tire. It goes back to consumers. If you purchase a tire, there is a benefit to road hazard insurance. So when you hear something in your tire or see a puncture or damage to your tire, such as this right here, you take it to the dealer. Make sure you verify if you have to come back to that dealer, if you have to go to a different dealer, and be sure that you educate yourself on how road hazard insurance operates. So obviously with this particular tire, if there was no road hazard insurance purchased for this tire, even though this tire is new, usually the dealers will try to work with you, but there are some times where if you don't have that road hazard insurance, you may be out of luck and have to purchase another new tire. But this is a clear example of why you should probably try to purchase road hazard insurance if it is available to you. Let's take a look at our next tire. This tire, very good example. This particular individual was in an accident with his vehicle and apparently initially saw no damage to the tire. They continued this tire in operation, but as we inspect this tire a little closer, we can see some telltale signs of what can happen after a vehicle accident. So as you look closer at this tire, you see this line within the groove area that goes circumferentially around the tire. Well, this tread is not designed or manufactured with a splice there. So we know that initially this is not a concern with the manufacturing process. So we get back to the vehicle, we analyze the vehicle, and then there is some trim that stuck down and did this kind of damage to this tire. Usually this can be found or caught by the body shop, but it is not an uncommon experience. But the telltale thing for us as tire engineers is that this tread is not produced this way. It is extruded through that type of process as a whole piece, same compound, and there is no splice here. So we initially know right off the bat this is not a tire issue. There is some external component that caused this tire to behave or caused this particular type of damage to this tire. In conclusion, tires are basically the only part of your vehicle, as we said earlier, that are going to come in contact with the ground. They determine braking forces, acceleration forces, handling forces, and transmit all those forces up through your suspension and your steering wheel to help you control your vehicle. If a tire has an issue, it doesn't. If you get a tire mounted on your vehicle and there is no issue with that tire, typically if something happens later, a vibration, a knock, a hum, there is some other force external of the tire that caused the tire to behave or caused the situation that you saw that tire in. For example, if a tire is out of round, it is out of round initially from the factory. It doesn't become out of round at a later date. That's not the way tires work, unfortunately. But if you ever have an issue with your tires, always contact the tire manufacturer and or go by the tire dealer to have them analyze that tire so that they can check that tire out and make sure it's in good enough condition to continue use. There are many different policies and procedures that are separated by manufacturer. It's always good to check with your tire's manufacturer to determine any issues or rebates or recalls with your particular tire. Also at the point of sale, you also want to fill out your tire recall slip. If there's ever a recall or an issue that the manufacturer has with your tire, they will be more than willing to contact you direct and inform you that there is a recall or some other issue with your particular product. But in closing, air pressure, very, very important. On behalf of Bridgestone Americas, Hendon Publishing, and Police Fleet Expo, thank you for taking time to view this video.